We're live.
All right. Okay, everybody. It's almost 7:30. We'll give it one more minute before I call the meeting to order. Thank you very much for joining us tonight. Whopping 4 days after our last meeting.
It's good to have them after
3.
days.
Oh, no, it's not. Maybe as an attendee, it's not good to be the president and have it every 4 days. All right, bottom of the hour. Let's call this meeting to order. Thank you very much, ladies and gents and friends and cousins and all that, for joining us twice in 1 week for the September quote unquote Macomb WAS meeting. Since we just saw each other, I think we'll have some abbreviated reports tonight, but in the meantime, got some things to say as your president for this year. Thanks to all of you who attended the swap meet. So it was our first face-to-face event since the March Cranbrook meeting of last year. I was dealing with family-related stuff that Dan could not make up, but Dale and Riyadh tell me it was quite fun. And I hope that it's the beginning of a new and better time for us. We're hearing encouraging things about vaccinations for kids, which is right now the primary thing holding us back on fully embracing outdoor activities because, of course, many of the public that we serve are small children. And the last thing any of us want to do is get small kids who want to learn about astronomy ill. As far as returning to our regular venues of Cranbrook and Macomb, we are waiting on guidance from those facilities. They do not have a transition plan that suits our needs yet. So as we coast toward the end of the year, we have several things that need your input as members of this August Society. First off, every year the Warren Club puts together a fabulous calendar of member astro images, astro photographs, astro drawings, and photographs and drawings celebrating the celestial phenomena of Earth. So aurorae, clouds, rainbows, cool stuff like that, because Earth is a planet with unique weather. So if you have an image to submit to be part of the 2022 WAS calendar, please send it to publications@warrenastro.org. If you would like to be on the committee that helps assemble the calendar, let the board know. We usually have a calendar committee of like between 1 and 3 people. Better of 3 because it's a lot of work. So if you have a good eye, data entry skills, and a knack for resizing images, please let us know so we can get this calendar made in a timely fashion. We like to order it before the winter holidays so that we can get them into people's hands in January. We are also in the process of selecting this year's Service Award winners. It has been a strange couple of years where we are not seeing one another at meetings, at discussion groups, at outreach events. However, everybody in their own way has been keeping the flame of amateur astronomy alive, be it online outreach events or working for the club behind the scenes or helping keep things like astronomy at the beach running in a digital fashion. So if you have people in mind that have done the good fight for amateur astronomy, send your nominations to the board. We will be happy to consider them for this year's service awards. Next month, that's October, is the deadline to be on the nominating committee for this year's officer elections. Every officer spot is up for grabs, term limits or no term limits, in November. However, thanks to term limits, Bob Tremblay is not capable of serving as outreach chair because he has done an unprecedented 3 years in that position. And the Constitution says he's getting a break. And we also know that Riyadh, our stalwart Stargate Committee chair, has taken a different job in recent years that prevents him from attending in-person meetings. He's been able to participate remotely because of the unique nature of this year, but he's not going to be able to serve as observatory chairman. And so if you would like to be observatory chairman, if you would like to be outreach, we want to hear from you. Quite honestly, if you'd like to serve in just about any capacity, we would like to hear from you. It's fun, trust me. So please reach out to Dr. Dale Parton at firstvpwarrenester.org if you wish to serve on the nominating committee. If you wish to be nominated for high office, one of the 7 positions, let the board know. We will make sure the nominating committee has you on the slate. Okay, if you wish to make the jump from amateur astronomy to professional astronomy, we have 2 employment opportunities of interest. One of them at Planewave is featured in the WASP. So there's a full job write-up in the WASP that we would think you ought to see. The other one is a part-time position at Cranbrook for the planetarium and the observatory. I will be sharing it in the chat. Cranbrook is, of course, one of our 2 host institutions when we can meet physically. We've historically had club members in that role. So if you would like to join the illustrious parade of WASP members working the Cranbrook Planetarium and or the Cranbrook Telescope, let us know. Finally, we have a special private screening of a film in lieu of a live presentation next month on October 4th. That's our virtual Cranbrook meeting. There will be a different registration link for that evening. We will not do a live stream. So YouTube is not going to be running that night. It will return for all the live presentations, but for October 4th, virtual Cranbrook, WebEx will be the only means of enjoying that meeting. So just wanted to let you know it will be included in the mail blast for that night, but just letting everybody know this is the place, the WebEx room. And with that, I've said quite enough, and I will turn things over to Dr. Dale Parton.
Well, thank you, Diane. As she said, at our next meeting on October the 4th, a representative of Calvin University will introduce a special video presentation called Luminous that deals with predictions that stars may explode. He will also be able to answer questions after the video. Then a month from now, on October 21, our quote-unquote Macomb meeting next month, Jonathan Cade will give a presentation on buying your first telescope. So if you know somebody who's kind of new or thinking about getting into astronomy, this would be an excellent, the typical question is, what should I buy? So, some of our presentations are kind of high level in astronomy. This one should be one that anybody can understand. So invite some newbies to that. Beyond that, I'm always looking for speakers. If you even have a glimmer, a wish upon a star that you could give a presentation on something, either a full-length presentation or a short one, please let me know. Diane, back to you.
All right, we'll turn things over to Riyadh with his spiffy virtual Stargate background that I love to see every time.
Yeah, thank you, Diane. Hello, everyone. Yeah, I visited the observatory on the 28th, actually, and the 29th of last month. Both days, everything was fine. All the equipment in good shape, buildings are in good shape. Of course, on the 28th, we did not have our picnic. However, it was a last minute thing. We had our swap meet. It was lightly attended, but it was not too bad. We had a number of members that came out, and we have a few things that were being sold, and people bought a few items. The next open house maybe, but I'm not sure. It could be a virtual open house, depending on the availability of Doug Bach. He may not be available. We'll have to wait and see. And that next open house is going to be on the 25th, of course, of September. So if he's available, hopefully we'll have another virtual meeting. That's all I have right now, Dan. Thank you.
Sounds good, Riyadh. And over to Mark Kedzier at secretary with a special report regarding telescope library projects.
Hi, thank you, Diane. Good evening, everyone. Got phase one done with the Ferndale Public Library. I did, along with Jeff Milo, one of the library techs there, and we did the heavy work and the modifications, got those all done. I actually gave them some training, how to get the red dot finder aligned with the main scope, and everything is in good order. I noticed on the Orion telescopes, on the red dot finders, if you're familiar with how the battery goes in the front, has that little clip, you gotta pry off the cover, try to slide it in. Well, now the new version of the red dot finders that Orion has, it actually has a little cover on the very top, and you just pry it open, just put the battery right in the top, so you don't have to do any prying off. So that'll be a quick and easy battery exchange on that. And the next thing we'll be meeting on the 27th to decorate the telescopes with labels, and we'll be setting up a staff meeting, and I'll be explaining how the telescope operates and everything, and then they're going to get their circulation policy in effect, and they want to have a launch sometime in October. And also the minutes are in the WASP for the August meetings, and that's all I have to report.
Very good. Thank you, Mark. Over to Adrian at Treasury.
This time I'll just do only the Treasury report, and it's really quick. We have $21,256.05 in the main account, $3,279.84 in the GLAC account. Still hasn't moved, and PayPal is up to $836.82. We've taken in a few membership renewals and some new memberships, which I'm actually drafting the email right now to welcome the members to the group. And our insurance with West Bend has been paid up. The bill was October, so I'm expecting the next bill to come out sometime first or second quarter of 2022, which is when I noticed we had paid the West Bend bill last time. So looks like we're paying this about twice a year.
Actually,
And
it's once a year. Last year
it's
was
once a
weird.
year?
Yeah.
Okay.
We are
That's
on time. Everything's good. No snafus. Smooth sailing.
okay. So that explains why I saw two payments for this year. So, all right. Well, like you said, we're on time and our insurance is paid up. We're still looking good financially, and don't know. I did also put our 500 in for Dr. Dale Pardon. Our 500 went out for the Macomb scholarship that you had asked me about. I think that was a couple weeks ago. As soon as you sent the email, I posted it straight to the website. They have an option for doing it every year. I figure next year, if we want to do that, we can plug in so that we can automatically send it to them every year, or we can vote on it however we want to do it.
Yeah, we'll take that up at the October board meeting, since their means of dealing with it, the logistics of it, have changed a bit since we set it up.
Okay, sounds good. With that, yes, I am. Most of what I pay and do is all online. We're making it easier to take care of business. The post office box still gets visited, and I've managed to visit once a week, and we'll try and continue doing that. We still do get some mail here and there. Dale, you have a question?
Yeah, I'm just curious. Do you know the approximate number of members that we have right now?
Yes, and I keep forgetting to mention it. Paid memberships are up to 183.
That's
Right.
like a massive record. I mean, that's really incredible. That
Yep,
y'all are fantastic.
we're getting, so Bob Berta deserves some credit for that, because I had emails coming in saying Bob Berta suggested that I send the payment, want to renew, want to become a member. So he's been doing some recruiting out there, and
Hey,
taking
that's
care.
the kind of thing we're looking for. We said, If we're not seeing something live at meetings, let us know so we can
Yep,
acknowledge
so
what people are doing.
there's a name for you. Bob Berta, probably responsible for 3 or 4 new members in the last month or so. And they've all been recorded in our spreadsheet. And I'm going to go back through it to make sure that I didn't incorrectly put a membership that started after July of this year to end it in December of this year. I realized that I may have done that for a couple memberships, but I'm gonna look through that and make sure everything's clean as far as when people have joined and when their membership should end. So other than that, I don't have anything new to report on the Treasury side.
Ah, it was all good. Over to Bob at Outreach.
All right. Well, I have to thank Mark. I've been holding off on buying a new telescope from Orion for I don't know what reason. And with the red dot finder, I think I know why. So I can buy my new telescope now. So I posted a link to the Astronomy at the Beach website in the chat. I worked on that today. I got several links that I added on there. For not having any programming scheduling, we're having a lot of programming scheduling on there now. We do have several people doing live telescope broadcasting. We had Doug Bach from the WAS, and we got Dr. Brian Adam both nights. And I had heard in the meetings that we were going to try and get a remote telescope from the southern hemisphere, which I have not seen anything on that, and I would really like that. So if anybody knows anything about somebody with a remote telescope from the southern hemisphere,
That was
that would
me,
be really
Bob,
cool.
and that's Maxi Falarius. He sent me his contact information, and I will be reaching out to him.
I'm going to be all over that. Okay, so my wife and I are starting up our astronomy club again. First meeting is on Monday, and over the course of the next year, I'd like to ask some WAS members to give a couple lectures, and that's going to be about starts at 3 to 4, so for like even 15, 20 minutes, sometime between like 3:30 and 4. That would be great. I'll get with you later on that. So astronomy at the beach. One of the links I got, Ford is using a single Zoom channel from 6 till midnight, which is genius. And they're doing several different things during that. And the last one, from 10 to midnight, or they say 11, probably midnight, is going to be a mega discussion group. It's just going to be a sit and chat. They got several people that are going to be talking with the public. So they're doing that both nights now. Not to be upped by them, I go ahead and scheduled myself to do a single presentation each night. If anybody else wants to do a presentation, that's fine, and everybody's invited to join in and kibitz on that thing, the Astro Hangout. So that's going on next week, and that's outreach for this week.
Fabulous. And then over to Dale Parton at the award-winning publications desk. Or Dale Teamy. Sorry.
I got the plaque to prove it. The WASP is online for September, of course, and the October issue is coming along very nicely at the moment. Once I get officer reports in, we'll be just about complete. So happy for that. Back to you, Diane.
Model of efficiency there. And you will be getting a movie review this time, come hell or high water. I'm off movie vacation, and I have a terrible film for y'all. Sometimes I think I enjoy watching the terrible movies more than the good ones. Okay, so that concludes our officer reports. Special subgroup reports. I was talking to Solar Marty of our solar subgroup last night. He said he hadn't looked at the sun lately. There was an explosion of sunspots earlier, but things seem a bit tame right now. Discussion group, of course, is currently tabled until we can meet again in person, though we do have a virtual discussion whenever Either Doug Bach is not available to open the Northern Cross Observatory, or the weather's lousy. And this is September. We are getting into the time of lousy weather. The Double Star Group, Riyadh, you had a nice piece to say last time. Could you say that again for the
Yeah.
Thursday crowd?
Yeah, sure. Thank you, Diane. Yeah, so in the fall, usually we have sometimes we have a really good conditions towards the end of the summer, beginning of the fall, where we would have good steady conditions that you could observe to look at some very small, very tight doubles. So that's something that maybe it would be a good time right now to go out and take a look. I would highly recommend you consider the area around Orion. There are lots of double stars in Orion. Of course, it's rising kind of early in the morning, so you may have to stay up late for that or get up early for it. But it's definitely worth it. Some of the most beautiful double stars are in Orion. So, and there are lots of multiple stars there as well. So take a look if you can. You will be rewarded. Thank you, Diane.
Question?
Sounds good. Yes, Dale.
What is a good double star that you can see in the evening sky now, in addition to Albireo?
Epsilon Lyrae.
Yeah, you could look at that. Of course, you could
Look at what?
always look
Iota
at,
Cassiopeia.
Iota Cassiopeia. So there
Epsilon
are,
Lyrae.
yeah, Albireo is good. So there are a few of them that you
Andromeda.
could look at in the evening.
Okay.
I think David had one to look at.
Yeah, David, you were saying
Gamma
something.
Andromedae is beautiful also.
You're right. Gamma Andromedae is beautiful. That is a good one.
Okay, thank you.
And it's in season.
It is. This is Andromeda season, for sure. Oh, oh, yeah, Bob's got a live feed of the sun. So yeah, very pretty in hydrogen
So,
alpha.
Yeah, there's some. Well, this is from the Solar Dynamics Observatory. You see that angry stuff rotating out of view. There's absolutely nothing on the face of the sun right now facing us. A lot of nice prominences, though.
Beautiful prominences.
So yeah,
Those
when this
spots.
thing resets, take a look at the lower right there, and you'll see a couple flares spout off right there. That thing was very active. Probably still is active as it's rotating around.
All right, beautiful. Well, I don't see Bill Beers. Doug, is Doug on the line? Will we get an astrophotography report? All right, refer to the Cranbrook minutes for the astrophotography report.
Well, I do have one. I repeated a feat that Dale Hollenbaugh has apparently done, taking a big 600mm lens and shot a perfect, took a perfect shot of Jupiter and Saturn.
Ooh.
And I think the Saturn, I'll share because I think I can find it. Let's see, I'll put it on screen too. The Saturn shot was in a parking lot at a bowling alley, and I said, hey, look at the moon, look at Saturn and Jupiter, let's take a picture. And I will see if I can actually find it. And unfortunately for me, I have no idea where I put it, but I'll try to find it right quick, and if I do, I will show it. Here we go. It is of these. And come on. Now, if this doesn't work in the next like minute or so, I will leave it to your imagination what it looks like. It would resemble looking at Saturn through a small refractor. So it's like you can make out the rings, you can make out the shape, but it's really, really small. And seeing how my computer is moving really, really slow, I'm not confident that I'm going to get it. And yeah, it's okay. It looks like it reorganized everything, so I'll try again. But if my mouse doesn't want to cooperate, I'm gonna quit. Okay, here we go. Try this again. And you aren't gonna pop up the image. So something's happened. I'm gonna have to clear my computer out because it is moving really bad. I gotta stop sharing.
Yeah, maybe you could share with us during the break.
Yeah, I'll try it again. Once something
Troubleshoot.
settles down here, I'll yeah, I'll pull it up and then I'll have it ready to share during the break. But it's Dale mentioned on Facebook that he managed to do it, and now he's in the wormhole of astrophotography. I'm falling back into the rabbit hole.
My red pill.
Yeah, I've taken both the red and the blue pill, and now I'm taking another red pill because it's
Well,
the
if
go,
no
Da-
one has
go
anything
Dale.
to share, I'll share a couple photographs I got just last night.
Sounds good.
Share. Screen. So I was trying to improve my photo and my capture. I've been doing this the past couple of weeks, trying to get the fifth moon Amalthea
Aha.
of Jupiter, and in trying to tweak the settings to really get that nice and bright. I'm pretty sure I managed to capture Phoebe, which I was not trying
Wait.
for and was pretty surprised
Oh.
/ impressed.
Phoebe. Wow. Yeah.
That is half the size of Amalthea. Now it is farther out and less. Can you see my mouse? I'm gonna zoom in here a little bit.
Wow.
So these diffraction spikes, I have like 7 different power lines to look through. So almost any time I turn the brightness up, I get diffraction spikes. So
How big is the scope you did this with?
11-inch.
So how big is Amalthea?
198 kilometers wide.
It's a pinprick. It's a
It's
real
a-
challenge.
It's a speck of dust.
I think it was it the only moon of Jupiter discovered post Galilean moons prior to satellites? I think that's its distinction.
It was discovered in 1890
Yeah.
something.
Yeah, it was the last moon of Jupiter discovered with ground-based telescopes, I think.
Yeah, this one I think was 1940s. That might have been pre-satellite.
Yeah, maybe they used
Yeah,
Palomar for that
this
one.
was pre-satellite with
Yeah.
large good equipment.
Yeah.
But well, the other thing I did was I captured 8 moons. I've previously done 7, but here's a picture of 8. Yeah, Mimas and Enceladus have to be sort of on the limb here, a little bit on the sides. If they're front or back, they're hard to distinguish. So I'm just tweaking my settings, taking more things, stacking here, try to get rid of some of this noise here. But that's a pretty decent image of Mimas. Hyperion is the faintest of the bunch. 16th magnitude, 17th. So these are like, I don't know, 2-second images and like a couple hundred of them stacked up. So here's where they were. I use this tool here because it uses JPL data. This is Stellarium, which is pretty accurate for the first 8 moons, but the smaller moons, the accuracy goes down. Likewise with Jupiter. It thought Thebe was over here, so I didn't show it on here. I sort of blanked it out, where it's really here. And Amalthea, I think, is actually slightly wrong. So the big moons, I think, are accurate, but the smaller ones are not. So this is accurate data here. So anyway, that's what I'm really been trying to eke out the fine settings to get those moons, and I pretty surprised I got Thebe here. So
Dale,
Nice.
if you go back to that photograph of Jupiter that you have with the
Yeah.
diffraction pattern, actually there's a technique, there's an older technique in observing very fine, very tight double stars, is to use a diffraction pattern like this, where you can rotate the pattern until you get the object that you want to observe in the dark areas, which is what's happening here in this photograph.
So
Which
how can I
will help you.
rotate? I would rotate the camera.
No, yeah, I mean, and actually, this was done in the past with visual observing. So you would make a mask that would have 6 sides cut. Basically, it's like instead of a circular mask, you would have a hexagonal mask, and you would rotate that until you get the voids in the image where you have the low diffraction brightness.
Okay.
Where the object that you're trying to observe, if it's close to a brighter star, for example, like let's say for Sirius, looking for Sirius B, this would actually help. And that's what you have here right now. This is what's happening.
I happen to get Phoebe in one of the darker zones here.
Yeah, exactly.
But if I wait, one thing I can do is, it's hard for me to see the power lines until I defocus it. Like when you're doing collimation, then I can see it either 1 or 2 right through the image, and I just wait 10 minutes and like, okay, it's outside the view, and then I focus it back in, and then these lines go away. But it's just the timing. It was about to hit the trees. I only have about an hour and a half to view them from where my primary scope is mounted. So anyway.
Yep. So
it's different conditions, and you're right, but that's interesting about the diffraction spikes. In some ways, it can help you, because earlier I actually saw Amalthea visually, and by visually I mean in real time on the computer screen without stacking, because there looked to be a tiny diffraction, just a little wisp. I couldn't see that. That was a surprise in the data, but I did see this, so I got the settings pretty good. This is with the 174 camera, which is commonly used for solar. Very large pixels, but it's sensitive.
It's amazing.
Pixels are like, I don't know, 2.5 times bigger than most planetary camera pixels. So a little bit more sensitive, and it's picking up more light because the pixel size is larger.
Nice.
So interesting. I think that really helped for me to get these. So anyway, there you go.
Very cool. All right, 8 o'clock. We have 2 brief news announcements tonight, because Bob Tremblay did a thorough In the News in the Sky on Monday, all of 4 nights ago. We've had 2 big stories since then. One, possible new impact detected on Jupiter by an amateur. So there's a link at Sky and Telescope to follow. It does not appear that there is a scar, but an amateur who assiduously observes Jupiter did detect the actual impact flash. So cool story there. Thoroughly recommend you check it out. The other thing we've got is, of course, the first ever all civilian private space mission is in orbit. Inspiration 4, a privately funded SpaceX mission that is raising money for St. Jude Hospital in Memphis, Tennessee, took off safely, and they are traveling in a surprisingly high Earth orbit that is on par with some of the old Gemini missions. So unlike the recent Blue Origins and Virgin Galactic suborbital hops, this is 4 civilians high above the Earth, where no NASA or JAXA or Russian spacefarer has been in a long time. And with that, let's have some observing reports. Raise your hand. David. David, your hand's up. You can unmute.
Yeah, I got to tell you what really is interesting about tonight's meeting is that I think it's wonderful to be able to see the progress of the Warren Astronomical Society under Diane's leadership in 3 days. We got a treasurer's report from Adrian on Monday. We got a treasurer's report from Adrian tonight. And we see a slight increase in the amount of money that the Warren Astronomical Society has in just 3 days. And we've had a lot of observing in the last 3 days. Two things. One has to do with this Jupiter thing. I have a mild interest in the planet Jupiter. And I believe that the night before last, I might have seen a very dark splat. We had excellent seeing. And of course, I don't know if the timing was right, but I did think I detected a splat, which I'd like to think is the dark remnants of whatever that flash was the other night. The other thing is the sun. And we saw the day before yesterday, one sunspot and a record for me, 41 prominences.
Wow.
And that really was something. So I'd like to read my poem of the 3 days. And this is from Leslie Peltzer's book, Starlight Nights. And kind of reminds me of the time before Wendy, when I was single and I would leave observatory domes open. Peltier wrote that one night as he was closing his dome, the shutter fell on him and broke his nose. And then after that, he kind of would, on a nice night, just leave the dome open. And remembering coming back from a date in town, he would suddenly have to interrupt it when the weather kind of took a turn for the worse. And so he had this little poem, and that's what I'm going to quote right now. Our hero felt the wind's first lash. He felt the distant lightning's flash. My dear, he cried, I shall return some other night with lips that burn. Right now I have to dash for home, for I forgot to close the dome. Thank you, and back to you, Diane.
I think any of us familiar with domes have a giggle out of that one. All right, more observing reports. I know the weather's been kind of rough, but we've had some beautiful glimpses of the moon, Jupiter, Saturn, Venus here in southeastern Michigan. Well, no more observing reports. I'll turn you loose for a full 23 minutes to hang out, chat, drink, share photographs, and we'll reconvene at 8:30 for the feature presentation. Have a free-for-all, gang. See you soon.
I also have a suggestion. The next time that you have a problem with your computer not showing the slides, one thing that I would recommend is to take your computer and throw it through the window out onto the observing field. And then you go outside, pick it up, put it back in, and it should work a lot better. I've tried that. And my computer works beautifully now after having suffered a few incidences like that.
I think Diane forgot to ask a stupid question. Anybody have any questions? They don't have to be stupid, but those are allowed. I have a question for Tony. Tony, you're the co-president of the GM Astronomy Club, right?
De facto, yeah. We lost Jim. He moved up north, Jim Goodall. He was a very good president, and I've never been a president of anything. And Tom also was vice president, and he's working full time, and he didn't have time to really step up to the duties of president. So we kind of agreed to be co-presidents.
So,
So yeah.
Are we officially on break, by the way?
yes.
All right, good. I can share this handheld Saturn shot.
So I was asking Tony about the GM Astronomy Club. Is the club very active these days?
It's not. It's just not active. But we're keeping the mailing list going, and we're keeping public observing. Our public observing is going to be tomorrow night, in fact. And so we're doing monthly public observing through the summer out at the vice president, at the, co-president Tom's house. And that's it for now. And so we just, our focus is on bringing observing to the public, beginners especially. And so we invite anyone from GM or elsewhere to come out and observe with us. So it's a very casual club, simply because that's what we have time to do.
Okay, thank you.
Yeah, we really don't have an observing site either. That's the other problem. With COVID, we have our observing site shut down, which is the Milford Proving Grounds. So we haven't been able to meet there, and that's where traditionally we met, and it was a very active club in those days. But now it's now who knows? After COVID, Tom and I might ramp things up again. But right now we're in a lull.
Thank you.
Well, the Plymouth Astrophotography Club is busy though. I've thought about having them become official GLAC members. And I have to resume the talks. I'm super busy taking handheld shots of stuff. So but I think it would be worth talking to Gordon about the Plymouth Astrophotography Club being a GLAC member. Right now we don't have anything in place in terms of like dues or anything active yet, because with COVID we haven't been able to do much other than an online sort of presentation. So now is probably the best time to jump in. But we'll see after this year.
Adrian, isn't the Plymouth Club just a spin-off of the Ford Club?
I don't know. It could be, but I just know that Tim from the Ford Club shows up there. But really, what I see are just a lot of astrophotographers. Jason Gunzel, a staffer for Explore Scientific, and then Douglas Struble, who he gets the deepest of the faintest fuzzies and digs in. We Dale Hollenbaugh, we just brought Dale. I think I pulled Dale about the club, and now he's a part of it. You've been a part of it for a while, and I haven't had a chance to meet with all of you all. My days, especially Tuesdays, with the Explore Scientific Star parties that I've gone to, my first Tuesdays of the month have been busy. I've got to find time to get back to one of these meetings and let them know I'm still alive and looking forward to Okie-Tex in a couple weeks.
Nice.
It'll be dark skies, and I'll be trying a bunch of different crazy things. So hopefully it doesn't rain most of the time or smoke out. I mean, it's still getting some wildfire smoke wafting around here and there. Tonight looks like it's going to be pretty clear, but of
it
course
looks awesome tonight. I'm sitting in front of a picture window here, and it looks, there's a light mist out there, which suggests that it's steady sky. So somebody who does planetary should have a very good evening tonight, and it's crystal clear.
Yep, I would say that might have been part of why I had the luck of being able to take a handheld shot last night was pretty steady too. And that's why I was surprised to see rings on Saturn on a 600 millimeter wildlife lens.
Wow.
So it's that was the image that I had shared earlier.
Mhm.
You saw the moon. Where's my
I'll pop it up there again. You were
yeah,
talking
I'm
when you
gonna
did it.
yeah, it's right here, I think. So I'll find out. As soon as it pops up, I'll share a screen. That was Jupiter. Jupiter didn't turn out too bad, but we've seen so many good images of Jupiter, we kind of know. Yep, you'll see it in a second. I'm just making sure it shows up. And then I'm gonna go to share a screen. And so what you're seeing is a shot that I took standing there holding a 150 to 600 millimeter lens and a Sony A7 III camera, and I aimed it right at Saturn.
Last
Said,
night?
let's see what we can. Yep. And I said, let's see what we can get, and I got rings.
Oh, very good.
Yep. That was a direct shot.
Very good.
Jupiter, fuzzy equatorial band here. You know, you've seen some better, even a moon, and I never did ID this moon. You can see better images of Jupiter, you know, with modest equipment, but the getting Saturn's rings is that's one of those things where I didn't expect to get the ring on both sides. You know, now it's not super perfect, but that
Nice.
turned out a lot better than I thought for a handheld. Now I have image stabilization, in-body stabilization, as well as on the lens. I think it's lens stabilization. I shot at a fast enough shutter speed to try and overcome the overcome the camera shake. Everyone kind of has a natural camera shake, but I've worked on being steady because I shoot at the moon a lot, and I
Nice.
try to go for some details when I shoot the moon.
Looks good.
Beautiful.
Yep.
Adrian,
wanted to-
what's the maximum focal length in your arsenal right now? I know you do a lot of wildlife and
Yeah, 600 is the max, and I haven't gotten a converter. So my camera has the option of going, I think this is Copernicus right here. It does have the option of pretending to be a crop sensor camera. So you get that 1.5 times, cropping factor, which it makes it seem like it's, what would it be? It would be like 800, 850 or something,
yeah,
but
but it's
that's
not optical zoom.
yeah, it's not optical. I mean, optically it's 600, and for me does pretty well as long as stabilization's working and I can hold the camera steady. Whenever I want a sharper image, I'll go for using a tripod like most folks do. I haven't caught this perfectly yet. I'm circling the lunar X, which when you view the moon at the right time, you that lunar X really pops out. And then up here below these it's hard to find when there's too much light, but there's a lunar V over here that around the same time, those two features, if the shadows hit them correctly, those two features wind up looking they stand out in contrast and form those letters. It's a tough target because you have to have the Terminator fall at the right time, right at in first quarter. It can be And that may happen when the moon is still below horizon or, you know, in daytime. So it can be tough to get. And I don't think all of the landing sites are visible yet. I think tonight they will be, but I think 12 and 14 over here aren't yet visible. Maybe 14, but not 12. We know 11. Let's see if I can find our landing zones. Where is 11? 11, I thought was around here. I thought 16, a little ways over here. I thought 17 landed somewhere up here. 15, Hadley Rill is here. And then 12 and 14 are, can't see it right now. I do believe those are the moon landings, but I could be off. 17 might be back here. I don't remember exactly, but I do believe that's where we landed.
Good job.
So I try to remember that when doing outreach and aiming something right at the moon or just showing the picture of it. But here, I'll stop sharing.
Yeah, people ask that stuff.
Yeah, and I've tried to memorize those spots. I tried to memorize them so that I could share. Be like, yeah, it's here, it's here, it's there. I suppose I should. I don't think I've done much. I have done some imaging. I'll share one more time. Where's the WebEx? While my computer behaves, I should go ahead and take advantage of that. I think I was having a network issue. Let's see what I have. If you haven't been to Lake Hudson, this is what it looks like.
That's pretty.
Kind of what it looks like now at the boating launch.
Where is Lake Hudson?
This park is in Clayton, Michigan. It is about an hour and a half west and south of Detroit. Best way I can describe it is Michigan Ave or Highway 12, coming from places like Ypsilanti or Ann Arbor to Highway 1. I don't think it's Highway 127. I think maybe Highway 156. But it's kind of a lower middle of the southern. It's a southern part of the Lower Peninsula, and it's about 30 minutes or so from the Ohio border. So it's a good place to observe. It gets to about Bortle 4 at its best, and using a modified camera, a fully modified camera, I tried doing some interesting Milky Way stuff, and
Pretty one
you can,
job.
with clouds and Milky Way, that's basically what you got. My tracking wasn't spot on. Here's a good panorama. Might be tough to see because it's so small. Facing out. So if you come to the boat launch and then face away from the actual boating launch itself, this is the image. This is what you see when you're looking south, from basically southeast to southwest. This is what you see. I was able to stitch this as a panorama, and Milky Way is kind of in the middle. There is a light dome, which is why the Milky Way kind of stops here. There's enough light pollution to wash out the rest of the galactic core. But it's
Adrian,
yeah.
in the early to mid 90s, we used to have a couple of, we've been there. We've had a couple of club campouts at Lake Hudson over 2-3 years or something like that.
I would love to participate in those again.
Yeah, we haven't done that in a long time, and I wish we could do them again. They were an awful lot of fun. People brought their scopes, and we were all together. It was, for a couple of nights. It was
Yeah.
wonderful.
It can get beautiful there,
Yeah.
but then again, so is this.
Oh,
Yeah.
This is off of the thumb,
I like that too.
and this is when you have the moon. You can still shoot the moon. These are stars from the constellation Camelopardalis, and at the time, Jupiter was here, and Saturn's one of these stars. I believe it's this one right here. And then these were stars from Camelopardalis. And this is one of the roadside parks that you can stop off. I believe it's the first one near Port Sanilac. Beautiful view. Because of where the Milky Way is right now, the Milky Way would just be this kind of a arc right here, and it goes on back here. So it's better to image the Milky Way when it's rising early in spring if you're gonna shoot east. And somewhere, here we go. This is one of the Alcona shots. Meteor. This was a grainier version of. I shot a few of them trying to make Alcona Dam Pond, which is not far from where the Great Lakes Stargaze is. The skies are really nice out there. I'll share a couple more images that I've taken. These are over the last month. Say hello to Andromeda and M33 and a number of other things. The clouds are covering them. And perhaps my favorite image from this time was this one. This one turned out pretty clean. There's a meteor streaking towards the south. And this is a stock camera photo. This was not a modified camera photo, but it was combined for HDR, and it turned out pretty good. I shot this right as the clouds kind of formed like this. I said, that's a cool way to frame it. You have a couple trees over here, so I do like this one.
Is that Lake Hudson?
That's not Lake Hudson, although it does look very similar. This is Alcona Pond at a campsite in Alcona County. It looks like a lake to me, but it's called Alcona Dam Pond. Dam as in the block the water dam. I guess there's one somewhere, and then there's Ausable River.
Ausable River. Yeah.
Ausable River, thank you.
Yep.
Flows into this. I've wanted to take a picture off of the road where you cross the say it again, Ausable River.
Yes.
Over the bridge. Unfortunately, I've waited too long. I don't know if I can capture anything of significance over that bridge, but it's a beautiful look. One of these days we'll catch the Milky
Alcona
Way.
County is where Jonathan and I have our dark sky site. So beautiful, beautiful area because nobody goes there.
Yeah, well, they do come to this camping site, so it can get pretty busy, but you get off to a little part. This is where Dr. Brian Autumn and I did some imaging. We had a lot of fun watching Perseids left, right, backwards, and forwards. Almost every image I took had a streak going through it from either Perseid or a couple of the other meteor showers that were going on at that time as well. Mostly Perseids, I think. It was a lot of fun back then, and the skies were dark. I have to drive 3 hours to see what you get to see every day when you go up there.
No, we still have to drive the 3.5 hours to get there.
Well,
We
yeah,
just
but
have a
then you
place to
stay.
crash.
Yeah,
Then we
I turn
stay,
around.
yeah.
I turn around and
Hey,
drive 3.5 hours back.
we'd be happy to host you up there post COVID.
I will take that up,
Or
and
you
I will
can
stop
camp if
sharing.
you're a camping man, you can camp in our lot.
I'm about to learn all about that at Okie Techs in about a couple weeks, so
All
I'll
right.
be
Well,
ready.
we have a lot, and we would love to host our fellow WAS members up there.
Looking forward to it.
By the way, please don't 30 of you show up at once. Like, talk to us first.
Will do.
Okay, 8:29. Let's get back in our seats. It is officially 8:30. We are back off break, and I will turn the mic over to Dr. Dale Parton to introduce our speaker of the night.
Thank you, Diane. Well, Tony is here. He was involved in some discussion during the break. He's our speaker tonight. He's a retired automotive sculptor, so like an artist in the Detroit area with a passion for astronomy. He is, as we discussed during the break, the co-president of the GM Astronomy Club and a member of the Ford Club. Most recently, he has taken up fishing, but you're muted, Tony. But at least mostly he's not fishing for fish. He's been fishing for meteorites in Strawberry Lake out near Brighton, Michigan. And it seems like he's now caught a big one. So, Tony, tell us about it.
Thank you, Dale. Much appreciated. I am going to get set up here. I'll share my screen. And
hey, everybody that's could everybody else mute your microphone as we get going on this presentation? Thank you.
So now I have to go share. I'm going to stop sharing. I have to do this right. We have to share file. That's right. Share my file. Next. Sorry, I have to think out loud here to get this set up. So the presentation is called the Hamburg Meteor, and that is what Dale was referring to that I've been fishing for. I was going to say I do fish. You know, I'm right here on the Huron River, and I grew up here. I'll say more about that later. But I do like fishing, real fishing, and that's why I moved back here in my retirement. But the Hamburg Meteor that came down in 2018 sort of got the fire lit under me to move back home. And now I'm living right here in a meteorite strewn field. And I'm happy to be back home right on the river, and I'm fishing whenever I want. Okay. Say okay to that. And so hopefully everyone can see my presentation. Do I hear some yeses?
Yes, we can.
Yes.
Okay, cool.
Looks awesome.
All right, so I'll just get started. So my name's Tony Licata, and I have, as Dale said, I'm a retired automotive sculptor with a passion for astronomy. I like that. I like how he said that, because that pretty much describes me. And I've been doing astronomy since I was a kid. And I used to hit the right button here. Oh, there we go. Yeah, since I was a kid, and I'll talk a little bit more about that in a second. But before I even get started, I wanted to just share quickly on the screen, so those of you who are listening or on YouTube can take a screenshot, because I'm going to refer to some of these resources during the presentation. And the main one here is Strewnify. It's Jim Goodall. He used to be the president of the GM Astronomy Club. And this is his website, his invention. And it has gone really big, global, since 2018 when he invented this. And it's become the premier site for meteorite recovery. And what it does is map the theoretical strewn field of any given fall anywhere in the world, and he's hooked into all kinds of other resources like the American Meteor Society and NASA, and all the camera arrays that are in various places globally to produce these strewn maps. So I'll talk more about that later as well. Also, the Peter Brown paper was the paper that I was privileged to take part in. Now I'm an artist, right? I'm not a PhD, but because of some of the work I was doing with the strewn field on the ground, I was invited to, plus I'm a meteorite finder, which kind of gets you into a scientific paper by default without a PhD. But there I am on a scientific paper, which I'm happy to report is getting a lot of attention. And so I'll talk more about that later as well. But there's the link if somebody wants to view the paper that the Planetary Science Institute wrote on the Hamburg Meteorite itself. Okay, so what happened over Hamburg, January 16th, 2018? So now I would like to navigate over to, I'm going to stop the video and we're going to look at some videos. Oh, no, our video. I'm gonna, let's see here. I'm gonna unshare. You can still hear me, right? And then I'm going
Yes.
to share. I have to share my screen now. I have to share my screen. And we'll look at some videos of the Hamburg Meteorite because the mode I'm in does not play video. So that was the only drawback. So hopefully we'll be able to see some of these videos live. I won't spend too much time on this. So we'll just open that with Media Player. So this is the Hamburg Meteorite over the GM Tech Center. Jim Goodall grabbed this video. And with this video, you can see it explodes, makes 2 air bursts, and then disappears into dark flight, it's called. And there are a few more. We'll try this one here. This one I just grabbed from YouTube. So a lot of great videos of what came down over Hamburg. Can everyone still hear me?
Yes.
Yep.
Can you see the videos okay?
Sure can.
Okay, so I'm gonna stop those and I'm gonna go back into my presentation mode and we'll get back going again. Oh boy. Looks like I went right. I don't find WebEx anymore. Oh, there I am. Okay. I'll stop sharing that and I will share my file again. Share file. Okay. So sorry that's a bit cumbersome, but so those were the videos. Now we'll move on to, so what was that thing coming down? There's a lot of people possibly listening from my observatory page that may not know this. I know you guys in the Warren Club know. Was this a meteor shower? You're not allowed to answer if you know. The answer is what came down over Hamburg is it was not a meteor shower. A meteor shower is caused by cometary debris. This is actually a video that doesn't play in this mode either. Of a cometary tail, a comet head breaking up. And what happens during a meteor shower is the Earth passes through the debris field of a periodic comet, and they're usually an annual event. And so what happens is you will see from a radiant point, like in this picture, you will see meteors streak across the sky over the course of, say, about a week as the Earth is passing through that cometary debris field. But that's not the kind of meteor that we're talking about when we're talking about the Hamburg Meteorite. What the Hamburg Meteorite is a bolide, and it's a completely different sort of object. It's from the early solar system, usually from the main asteroid belt, and it's a rock. They're either stony objects or they are high nickel iron content objects that come in from the asteroid belt. They're pulled in to Earth's gravity, and they fall to Earth as a bolide meteorite. Usually they're larger rocks, and they don't accompany a meteor shower usually. So when this happened in January 16, 2018, I was up at my observatory up north. I used to have a cottage in a dark sky site, and this is my little dome. That's my cottage and the telescope inside. So I was there imaging, I think it was a comet at the time, and I was 200 miles away and I saw a flash. I had stepped out of my observatory briefly just to check the temperature because I was freezing. It was really cold. It was like -15 up there. And I wanted to know how cold it was because I was shivering. Just as I stepped out, there was a flash in the sky. And I didn't pay any attention to it. Now, since that day, I'll say more about that in a second, but since that day, I moved that observatory down to the Huron River where I live now, and we sold that cottage. But that flash was, as I went in to warm up later on, I was in contact with my friend Todd Slisher, and I'm going to bring my notes up here. And hang on. There we go. Sorry about that. So I was online with my friend while I was up at the cottage with my friend Todd Slisher. He used to be president or director of the Detroit Science Center. He's now directing the Longway Planetarium up in Flint. And that's where the meteorites, by the way, are currently on display if anyone wants to actually go and see the Hamburg meteorites. So that's what happened in Hamburg was a bolide went over, and this was Todd's video. It was a nest cam in his backyard. And so I was online with Todd, and he saw the flash, and then the news broke, and I realized that, my goodness, I have also 200 miles away, I saw the flash to this meteor. Now down there, they heard a boom, and Todd heard a boom. And so we began chatting back and forth along with Jenny Pond and some other club members from the Farmington community stargazers, and talking about maybe getting together and maybe trying to figure out where this thing came in and landed. So Todd got to work, and based on that shadow transiting the deck, his deck, this is his deck, this is the peak of his roof, and that prior slide, that's the peak of his roof, and it kind of moved this way. This video doesn't play either, but we need to move on. I'm trying to blow through these slides quickly. So this shadow of the peak, when the airburst happened, it showed the peak over here, and it traveled. Oh, let me get the laser pointer. I think there's an option for a laser pointer. Laser pointer. There, can you guys see that?
Yes, we can.
Good.
I just
So,
learned there's a
now
laser
I'm
pointer
pointing to
here.
stuff, and you can see what I'm pointing to. So this is the peak
Cool.
of his roof, and it kind of transited this way. And Todd also heard a boom But the boom, there was a delay because the speed of sound is slower than the speed of light, and so he calculated the delay of that boom. There was a sound delay of 104 seconds, and 104 seconds. That seems like a lot, but that's what he wrote down here. These slides are courtesy of Todd Slisher. These were the numbers that he plugged into some simple geometry that he did. And there's his scribbled notes. And he came up with a figure that this meteor must have come down 14.84 miles from his house. And so he plotted that on this map. And you can see here's his house in New Hudson. And here's Hamburg Township. These are the lakes that it came down in. And we found our specimens here on Strawberry Lake. But here was Todd's calculation. He's spot on, except he's a little far north. And so when he figured this out and we were online chatting about it, we thought, and some people were saying it was in Mount Clemens because there was seismic data and such. But Todd was really the first one anywhere that figured out that it wasn't at Mount Clemens. It was in Hamburg. And so we were ready to drive there already at that point, but it was kind of not, we weren't sure. We had never done this, but none of us were at the time meteorite experts. And so the next day, however, a guy by the name of Mark Fries from the Johnson Space Center reached out to Jenny Pond, who was with our club at the time. And she was friends with Todd and me and another guy by the name of Rod Landis, who was the director of planetary defense. Yes, that's a job. And he shared this image of Mark Fry's work. And what Mark does is he plots Doppler radar data over the Earth and produces these maps of something that was producing Doppler hits that wasn't rain. And so he's got this all these marks over the lakes. You can't even see the lakes because he got so many marks. But Strawberry Lake's under here and Bass Lake out in Hamburg Township. And it's covered with radar hits. Once we saw that, we realized that Todd Slisher's calculation was pretty darn close. And we figured there must be, and in fact, Mark Fries was also saying that there must be meteorites on the ground. So the next day we went out there. There were no reports of meteorites yet, but later we learned that there were some finds already taking place early in the morning. This is Larry Atkins and this is Robert Ward. And they were the first to get on the lake. They weren't actually a team, but they know each other and they wound up meeting on the lake. And so they obtained permission to get on Strawberry Lake. And they were the first ones to recover rocks. I was way up north rushing home, buying a metal detector. You can see that in my hand here. And this is Todd Slisher here with his find. And this is Brian Wolf, who also found the largest in our little team. So these three guys above, we got there a little bit later and had already, by the time we obtained permission to get on Strawberry Lake, they had already recovered rocks. So we were kind of second to the dance here anyhow. And so you can see it was just a great day. Hard to describe how much excitement it was to be able to find meteors. We didn't really know, these guys knew what they were looking for because they're professional meteorite hunters. Robert Ward flew out all the way from Arizona because he heard of Mark Fry's Doppler data as well, because those guys are right in touch with those resources. We were not, and so we were a little late, but I think we did pretty good considering we were competing here with professional meteorite hunters that travel the globe doing this sort of thing. So anyway, this, let me go back this rock up here in the corner, that's the one that I found. Mine was the second rock. Todd found his first, and it was something around 10 grams. Brian was the last one to find, and his was about 27 grams, and mine was about 16 grams, about 1 inch in size. And you can see a little of the fusion crust has chipped off there. But so what we did that the other guys didn't do, though, is you can see Todd's wrapped his in aluminum foil. And I did the same with mine, so did Brian. And we sent these specimens out to NASA so they could do some cold studies. And they haven't been touched by human hands either. So that became a valuable resource for study, scientific study. Later on, I'll say more about that. So the other thing we did as we were finding rocks was take a picture in situ, because that's also important as we map the strewn field, also to document the condition they were in while they were still on the ground and untouched. And it's important to note that these things are already on ice, okay? They really haven't been damaged by water, because the water is solid at this point and it blows right off of them. And so we could bag those things in aluminum foil, because aluminum foil doesn't have as much organic material as plastic bags do. So all of this we rushed to learn up quickly. And so we got our rocks bagged and ready for study. And there we are out on the lake walking. It was freezing, but we were finding rocks. And as we walked down the length of Strawberry Lake, which became what we thought might be the center of the trajectory, we kind of spread out and walked the length of the lake. And the rocks were getting bigger. Todd was the first to find his on the eastern side of the lake. I found mine as we walked farther west, and then Brian found his all the way down to the other side of the lake, and they were getting bigger as we went farther west. And so now the search continues. The next morning, night fell, and we met at the house and we took photos of the rocks, which I'll show you later. But what I was doing all along was, this is kind of my scribble. We've got Mark Fry's data in the red here, and I was just trying to document where these rocks came down so that the next day we could get out and maybe find other places within the radar blips that might contain rocks. And I noticed that if we strike a line through the center of our finds here on Strawberry Lake down to this is Hamburg Lake, and this was kind of at the time what we believed, down the center of the red area, which was where we thought the rocks were coming. So we figured that Hamburg Lake might be a good place to search. And sure enough, when we got there, we met a guy named Brian Barnibo, and he had a rock in his hand, and we asked him where he got it, and he didn't want to tell me. And I had mine that I found with me, and I showed him mine, and I told him where I found it. I said I found it on Strawberry Lake. And after he saw that I was being upfront with him, he disclosed that he had just found that rock there on Hamburg Lake. And so that's confirmed a trajectory for me. And so if we go back to that slide, that's when I struck this line here. And so we kind of walked this line along the length of Hamburg Lake. And sure enough, my daughter, this is Esther, my daughter, she picked up a rock on her magnet, and sure enough, it was a very tiny but beautiful specimen. And I still have that one in my collection. That one's not on display at the museum. But I didn't really know what I was doing. I just thought, well, let's try to walk the center of this trajectory. But really, meteorites, when they come in, they kind of draw an oval. And you can kind of see that all of these dots here are the documented meteorites. I don't believe all the meteorites that came down are documented. This is probably about half of them, and the rest of the people just never told anybody. But they kind of scatter and theoretically draw an oval, and you can kind of see that kind of scatter pattern here. It's called a strewn field. But in reality, this is when my friend Jim Goodall got to work writing this strewn lab program. It's a MATLAB program, if any of you know that soft how to it's for engineering, and he's an engineer with General Motors. But so the reality is, so you can see there's Hamburg Lake, Strawberry Lake, and Bass Lake are right there. And the hot spot is the larger rocks. And as things get blue, they're smaller and smaller. But you can see because of wind currents, now his program that he wrote takes into account wind currents at every layer of the Earth's atmosphere, and that were reported for that evening. So he goes out and grabs, the software goes out and grabs all of that data, and then all of the dynamics of falling rocks of various sizes. And that's all factored into this incredible software that he wrote. And it plots out a distorted oval because the wind takes that oval and kind of scatters it. And what it shows is, if you look here down on Hamburg Lake, it's in the blue area. That's why we were finding the smaller rocks there. Sure enough, it's true to form. And the larger rocks were right here over Bass and Strawberry Lakes, where we did find larger rocks. And so did Robert Ward, who found the main mass, which was it was just over 100-gram specimen, which is a pretty large rock. But you can see over here on Ore Lake, this is where I grew up. This is my house where I grew up, is right there. I realized that Ore Lake was in the strewn field. So we started off the next day, and by now things had melted and refroze a little bit. And so it was getting pretty slushy out there, but I went out onto Ore Lake, and we had magnets with us. And we found this rock. And actually, I've got that a little backwards because it's been almost 4 years now. I had found, we did that probably 3-4 days after the fall. So this is like on, I would say, January 21st, right? We found this rock picked up on my magnet. So it was magnetic. You can see this olivine crystal here. You can see some fusion crust on it. But at the time, I thought that Ore Lake was not on the strewn field until Jim came out with this, and that kind of brought this into the realm of possibility of being a meteorite, and it still is. So that one finally is about, we're calling this about 80% confirmed. So now let's fast forward. So there was a spell there for about a week or two where we didn't find, let's say 12 days, where we didn't find any more. Nobody was finding any more meteorites after those first few days. And there were hordes of people out on the lake looking. And so I believe all of the rocks that were on the lake ice were found. But the lakes thawed, there was a thaw, and then a refreeze. Now it's 12 days later. Most of those rocks would have been under the water by now. They would sink because they're dark and they heat faster. And so they melt little holes in the ice and sink to the bottom. So all the ones on the lake ice were lost. So we got the idea to maybe let's mount a land search. And so Team Slisher got together again, and this is Mike Bruno here, also from the Ford Club, who joined us. This is Jenny Pond and Todd Slisher and myself. And so we started scouring ground that we got permission to hunt. And well, sure enough, we were almost skunked that day and started back through the woods. And as we cut through the woods to our car, I noticed a gray rock sitting on the ground. And it was basically this rock right here, this 14-gram specimen, but it was gray side, broken side up. And as I waved my magnet over it, it stuck to the magnet, and there it is. So I didn't get an in situ picture of it, but it turns out, and Todd was right there, and he was one of the AMS, I guess you'd call him I don't know, they gave him a name. He was officially assigned by AMS to determine whether things were actually meteorites or not. And he came over and confirmed that it was a meteorite right away. And yeah, I was at this point, you know, fist pumping. Like this one, I have to say, I was more excited to find this because no one had thought they would find any more at this point. And I was fist pumping like Tiger Woods at the Masters, right? And it was just an amazing day, and it's really a beautiful specimen too. So this rock later went out for study by the Planetary Science Institute. So there it is again, stuck to the magnet. It's about the size of a little bigger than a nickel. And this is just for reference, this is my daughter's rock. This was the little hole it was in. You can see the lake ice was, this is on Hamburg Lake, was getting kind of slushy, but so the rocks kind of melted a hole. She saw that hole and reached down, and sure enough, she found that meteorite. So now we'll just look at some close-ups of the rocks, and we'll talk a little about what they are. All right, so the Hamburg meteorite is what's known as an H4 chondrite. And that means that it's a stony meteorite from the early solar system. It is undifferentiated. It has not ever gone through any differentiation, it's called geologically, as planetary bodies form. They form layers like a core and a mantle and a crust, right? Like the Earth, that's a planetary body, and it forms a core and a mantle and a crust, and that's called differentiation. But early solar system bodies from the early solar system, I guess, when they're not large enough, they don't differentiate. So, but they do form asteroids, and that's what's out in the asteroid belt. And so they tend to be stony, and they're made of these things called chondrules, which is just interplanetary dust, basically. As asteroids collide in the early solar system, they break apart, and there's dust everywhere, and they coalesce, and they form other bodies that are made of these little chondrules. They're round little spheres of early solar system material. And I don't have the exact age, but some 4 billion years old, right? So they're some of the oldest things in the atmosphere because they're undifferentiated. So they're interesting in that respect, but they're known as ordinary chondrites because they are the most common meteorite found. The nickel iron meteorites that have gone through differentiation broke off from the core of a planetary body that had undergone differentiation. While those are going to be more iron rich, nickel iron rich. But these stony meteorites are just that. They're made of just rocky looking things. They kind of look like gravel. If they didn't have the fusion crust, they'd be hard to tell from a regular rock. So this is my daughter's find. This is my find on Strawberry Lake. And then this is some stuff my son found on Bass Lake. But it turned out that was just some hematite that Larry Atkins had dropped from his from his magnet, and so it was kind of a false alarm. And then here's a close-up of the one I found on land, and this is one of only 2 that I'm aware of that was found on land. You can just see how beautiful it is. If you get really close into this, you can see these shocked cracking in the fusion crust, and some melting. You can see that these things don't actually burn when they go through the atmosphere. Then they slow to terminal velocity, and then they burn out and reach what's called cold flight, and then they drop to the Earth at terminal velocity. But you can just see how it's melted and fused. The stony material together into this black crust. And that's one of the identifying features of these Hamburg meteorites, is the black fusion crust and then the interior stony matrix. And you can see the little flecks of nickel iron that are already beginning to rust, because this one was sitting on land. It had seen moisture already, like the other ones had not. And so they didn't really show signs of rusting, but this one was already rusting when we found it. But that's also why they stick to magnets, because of that iron content. So those are some of the identifying features to this meteor. They stick to magnets, they've got the fusion crust, and they've got the gray stony chondrual matrix. And yeah. By the way, there's a lot of rocks that stick to magnets that are not meteorites. And Hamburg Township, we learned, is full of them. There's a lot of hematite in Hamburg Township on the ground. There's a lot of slag. And so this is my friend Samer Hariri. He was a professor at Oakland Community College, and he has since moved on, but he was another AMS rock identifier to rule out things that are not meteorites. And here he is looking at some of the specimens that I brought in. And you can see here also these melted olivine crystals. This is a close-up of the fusion crust. This is my daughter's specimen, and you can see the beautiful gray interior matrix with little beads of melted fusion crust in the broken area, little round spheres of melt from the crust. And closer in, you can see olivine crystal or some kind of metallic crystal there, and then even a thickness to the fusion crust. So really beautiful specimens. And this is how Samer was, he was putting everyone that came in under a microscope and either classifying them as meteors or meteoraints. So finally, then, as Robert Ward, the Ward Atkins teams submitted their rocks first, and they got into the Meteoritical Society bulletin. And so this is what they do when a meteorite comes down: is they classify it, you know, and they do a write-up on what its makeup is, and it turned out to be an H4 chondrite. There's different kinds of chondrite. H4 happens to be more of a higher iron content stony meteorite than what's called an L chondrite. They're lower iron content. And some of the other science that we did, this is another slide courtesy of Todd Slisher, as he turned in his cold samples that we kept on ice and in the dark and wrapped in foil. He submitted those to NASA, and they sent the rocks out for various types of tests. I'm sorry, but this, we'll blow through that slide. This is the chart I want to see, where there was cold work done by NASA and warm work. And so as received, and they did all kinds of things: X-ray tomography, Fourier transform, infrared spectroscopy, thermal gravimetric analysis, X-ray absorption, near-edge structure spectroscopy, pyrogas chromatography, mass spectrometry. And so they did some of the material went through cold work, and they did warm work. They allowed the rocks to thaw, and they did all kinds of tests on those. And that gave NASA the ability to really know, because these were such pristine samples, they really got to know what the makeup of these H4 chondrites were. And later it came out, I'll just say it now, that there was organic compounds in the H4 chondrite. Now, it's always been known that they had some organic compounds, but it was never believed that they were as much as the organic compounds, that is, were as much as what is in say, a carbonaceous chondrite. Those were known to have lots of organic compounds in them. But because these samples were so pristine, they could absolutely rule out the fact that they might have been contaminated, and that the organic compounds actually came from the rocks themselves. And so they're very near as much organic compounds as the carbonaceous chondrites. It was discovered later on as studied through these NASA studies. So the rocks became very valuable to science, which is really kind of cool. And so also, I did some work with the Planetary Science Institute. They found out that I found that one rock that you saw earlier, the one that had broken that we found on land. And so I was approached by the Planetary Science Institute for them to do some research. They wanted to write a paper on the orbital dynamics of the Hamburg Meteorite, so that they could determine what the possible parent bodies it came from out in the solar system. And it was determined in this paper, just briefly, that the parent body wasn't what they thought it might have been for the H4 chondrites, but it left it open-ended. So we actually know less than we did before. We thought, before the Hamburg Meteorite, they thought that these parent bodies came from a certain set of possible asteroids that are out there. But in fact, it came from none of them. And so it's back to the drawing board as to where H4 chondrites come from. But at least we know what we don't know. And that's what this paper kind of confirmed. And so it's getting citations just because of that, because even knowing what we don't know advances science, because you're not barking up the wrong tree anymore, so to speak. And so that's what the paper that Peter Brown was the head of it. The guy that contacted me was this Jordan Steckloff. There I am, Samar Hariri, with his research he did, got on the paper as well. So proud of that. And if you want to get an actual copy of it and read all about it, it's pretty technical, but Cornell published a free version of it, so you can download that here at this link. And this was the one we published over at Wiley. All right, next slide. So this is kind of my contribution. I went out and I went door to door asking people and interviewing people that actually found rocks. And I put together a little table of all the rocks, not only the ones that were on AMS website that people were willing to report, but other rocks that Samar had interviewed people, and I kind of pulled that all together into one little table, and that's what they used in the paper, the Peter Brown paper. And just here's a picture of all the people that found rocks that day. Those first few days out on the lake ice. Brandon Weller, and this is Robert Ward. He found 3 specimens. The largest was this one, which is the 100-gram specimen. And so they're calling that the main mass. Now there still might be a bigger rock out there, but this is what has been found. There's a swamp just west of Bass Lake that we think possibly a larger rock would have gone into that swamp, and it's just never been recovered. Probably never will be. But this is, it was just such a great opportunity. These things just don't happen where black rocks fall on froze, it was a cold snap, so the ice was thick. There was a layer of snow, so they stood out against the white snow. It was just, for meteorite hunting, this is as easy as it gets. And it was a super exciting few days as we were out hunting on the ice. And it's gotten harder and harder and harder now that the search has turned to land. Now I live here in Hamburg, and I don't think another rock will ever be found personally, but that hasn't stopped me from looking. So I'll talk a little bit about some of the efforts for our ongoing search. This is me here. I'm making this. This is a defunct Tasco telescope from the 70s or 60s that I had. And I turned it into, I aligned it, I glued a bunch of neodymium magnets to it and turned it into a magnetic roller, and went out into the fields and rolled for acres and acres. And we picked up a bunch of schmutz, and some of this stuff could be meteorites, but it's so tiny, it's hard to say. We never really got any really big chunks that we could easily see is a meteorite. But we definitely have some candidates out of it, and they're sitting in my collection, kind of gathering dust. I'm not really doing much about that. But some of those are, and some of those are not meteorites. But this thing would have, when it exploded, it probably, there's all kinds of size material on the ground. Some other work we did, this is Sammer here. He went around various lakes and ponds, and wherever we saw what looked like a suspicious hole that might have been this hole was frozen over, but you can see the cracks. We thought, maybe a big rock went in there. This was downfield. And so there's Sammer doing some magnet fishing as we reopened that hole. And yeah, more of the same. And then here I am rolling the fields. We got permission from Manly Bennett Park you're not really supposed to pick up rocks there, but we got permission from the township to do some rolling on the baseball fields there and the soccer fields. And this is Jesse Mason, my other friend, professor at OCC at the time as well, with his magnetic roller. And we swept these fields pretty good. And there were a couple of rocks that were found out there, but this far after the fall now, this is some month or two almost after the fall, we were not finding any more rocks, except for the little tiny pieces that you saw earlier. And some of the other things we did, this friend of Jim Goodall's was a diver, and so Mark Provost, he actually went into that pond where Sammer was magnet fishing when spring came, and he dove down there and looked, and he found it's on a golf course, and he found a lot of golf balls, but he did not find any meteorites. Then we did some, this is Kyle Souls. He is an expert drone operator, and he also, this is him with his little magnet sweeper that he made, but he flew his drones around Hamburg Township all over the place, on top of schools and buildings, and all over, looking in places that the hordes of people might not have been able to look. He was able to get to with his drones, and that didn't really prove to be productive either. But we tried all kinds of things, and so later on, then we hosted some presentations on meteorites. This is Larry Atkins. He was one of the original finders with his meteorite collection, and he is a very famous meteorite collector, along with Mark Jeffries, who's president of the Oakland Astronomy Club. And here he is with his impressive collection. But here with the GM Club, we were hosting some meteorite hunts for a while there. And this is one of our meteorite hunts that we went on. And we've had several since then. But no, to my knowledge, no more large pieces have been recovered since the last one that I found there in the woods on January 27th, 2018. No more large pieces, although there has been some small fragments, like I say, that we picked up that are, it would cost a lot now to have them analyzed. They're too small to really confirm or rule out, because they really have to be looked at. You have to look at the chemistry of them to really determine whether they're meteorites, because they're too small to visually make that determination. And so there's still a lot of ground to cover, but we continue, to go out with metal detectors. They are findable with metal detectors, but they're not very effective on these H4 chondrites because they are low in iron. So you have to get very close to them. Now they're under the leaf layers and in the wooded areas and in the swamps. And so it's getting harder and harder to find these precious messengers from the early solar system. And so lastly, I'll just show these links again. Again, the strewnify.com, that's Jim Goodall's resource that if you are interested in meteorite hunting, you can go here and learn all about what the experts do. When any rock comes in anywhere in the world, if you have the resources to get on a jet and fly out and hunt for meteorites, this is your go-to place to map where the potential theoretical strewn fields for any event that comes into our atmosphere, any rocks that potentially could fall to Earth. And Jim can tell you that with his plots, whether it's likely that there's rocks on the ground or whether it burned up in the atmosphere. The other great resource is the American Meteorite Society, and that's their link right there. And then some NASA links. Here's Dr. Mark Fry's Astromaterials Research and Explorations Meteorite Falls link right here. Okay, and that's it for my talk, and I can just open it up for questions. I hope I didn't go over time. How long did
Oh, no, that was fantastic, Tony. We have a solid 10 minutes for questions, and I must say that was
Cool.
a great deep dive into how amateur astronomy and professional science all mesh together in the present day. So let's have some questions.
I just think this was totally neat. A whole, it's a different dimension of astronomy. You're not just collecting meteorites that, you bought from someplace, but going and finding them, having some science to guide you where to look. That's
it was Dale. And the thing is, I've been an amateur astronomer since I was a kid. I didn't mention this, but I recall growing up here in Hamburg Township. I grew up there on Orr Lake. I would go out as a kid and watch the Perseid meteor showers, and I would imagine as a kid, boy, would it be neat if a meteor would hit the ground. Man, I'd be the first one, I thought, to go out and go hunting for them, but I knew it was nearly impossible for that ever to happen. But lo and behold, fast forward 40, 45 years later, it actually happened. A meteor hit the ground in my hometown of Hamburg Township and actually landed on the lake I grew up on. And I found one on the lake I grew up on. And yeah, it was pretty phenomenal as an amateur astronomer, to your point, to actually experience this other dimension of the hobby. As an amateur astronomer, I'm an avid astrophotographer. I've been now since around 2000. Yeah, I didn't know much when I started about meteorites, but I sure was excited to learn and learn fast about meteorites. And by the way, when they're on the ground, they're called a meteorite, but
Right.
you'll refer to them as meteoroids or meteors before they hit the ground. A meteoroid is one that's out in space still. Maybe it's in orbit around Earth, potentially ready to come in. As it's coming through the atmosphere, it's a meteor. And then when it hits the ground and you find it, it's a meteorite. And so those are the terms.
Tony?
Yes.
Tony, you were talking about the size of some of these meteors,
Yeah.
that you cannot tell whether in fact they're a meteor or not. Could you elaborate a little bit about why you talk about the very tiny ones that you really don't know?
Well, the very tiny ones, sometimes they could just be a little bit of fusion crust. They don't show perhaps we see something that looks like fusion crust to us, but we don't see any of that gray material, interior matrix, for example. And there are a bunch of rocks that look like that. Example was the ones that my son found. You saw that little patch of them. A lot of those may be, I mean, some of that might be fusion crust that just broke off from a meteorite that hit the ice, and we picked it up on our magnets. It's magnetic, but we don't see that gray matrix. So visually, we cannot make that determination. It doesn't have all the characteristics of the Hamburg meteorite. To make that visual determination, you need to be able to see all those characteristics. Others might be just a gray rock with no fusion crust. It may have broken out of the interior and all of the fusion crust broke away. There are some larger specimens like that, but there's no smaller ones like that. But I have some in my collection that look like interior matrix. And I really do need to send those out for analysis, because they could well be small fragments of meteorite that are not, they don't look like hematite, but they're gray magnetic rocks. They don't look like slag. So I do believe they actually are fragments of the meteorite, but I can't readily visually make that determination because I don't see fusion crust. And so Sammer couldn't either, and he's my source for identifying whether they are or aren't. So we both studied them under the microscope, and a lot of them, yeah, we think could be, but we can't rule out the possibility that it's just a gray magnetic rock.
Thank you.
Tony, I have a question. Was there an estimate made of the mass of this object?
Yeah. And it's a good question. I'm really sorry. I don't have the answer ready at hand. I don't want to be in error when I say it. But it was it was believed to be about 2 feet in diameter, right? So less than a meter, the original mass, and then the total mass that came down that actually hit the ground. Well, it isn't very much at all. It's no more than 500 grams of material that actually was recovered. But what was out in space in the bolide that came in, it was much bigger. They estimate around 2 feet in diameter. So the actual number of the mass doesn't come to mind. It's in the paper though. If you want to go to the the paper we wrote.
Okay, thank you.
Mm-hmm.
So Tony, about a month ago, it was August 15th, I saw a fireball and reported it to the AMS. And like a couple days later, they said a whole bunch of other people, and I looked on their map and everything. And it landed in Ohio.
Yep, I noted that one, and
I just checked your Strewnify website there that you listed, and I don't see it. So I don't know if anybody recovered anything.
Well, nobody actually went because it was believed that there was no material on the ground. Jim Goodall did an analysis on that, and we did talk about it there in one of our discussions. The one that came in Ohio, and we decided that
air too much, right? Maybe.
Although Ohio's pretty close, we decided it's not worth the drive because it was very unlikely that any material was on the ground. Jim can actually, at Strewnify, he can actually make that determination whether it would have all burned up in the atmosphere. And they also do studies on that at NASA as well. And they all collaborate and kind of decide together. And there's discussion boards there where they kind of agree that it's probably not worth the effort. So that's kind of what happened with that Ohio one.
Okay, so that was a recent memory. It was the first one I've ever seen. So
yeah, but that doesn't mean there isn't something on the ground.
Okay.
But nobody's gone and looked, and so if you wanted to, you could probably go to Strewnify, contact Jim, and ask him for the maps of where that strewn field might be. By the way, one thing I've learned to do for Strewnify, I'm one of the Doppler researchers at Strewnify, and so what Jim will do, and he does that now too, is we'll run our own Doppler, the same kind of thing that Mark Fries is doing with NASA. We'll run our own Doppler plots and see if we see any hits. And we didn't see any likely hits. So what we would like to see when a meteorite comes in is not only reports at AMS, visual reports, and not only Jim's potential theoretical strewn field map, we'd actually like to see those maps corroborated with actual Doppler hits. That would indicate rocks on the ground, just like you saw for the Hamburg Meteorite. And we've yet to really see that for any local falls, like the Ohio one. And there was another one that came just over, I think it was Lake St. Clair.
Yes.
Just hit in East Detroit somewhere.
Yep.
But it's not likely anything actually made it in. They just went through the dynamics and realized that it most likely all burned up. And so nobody actually goes out and looks in those cases. Sammer did kind of go and look for that one in East Detroit on the east side. He didn't find anything, and no one else really took the time. But when it's really likely, you will see that corroboration between the Doppler radar and the strewn field map that's theoretically generated, along with corroboration at NASA, and along with visual observations as well. And so all of that together kind of helps us determine whether we think rocks are on the ground or not. Do we know for sure? No, we never know for sure. Something could always make it to the ground. As it reaches free fall and burns out, there's always some kind of dust that might come in, but by then it's going to be so small and virtually vaporized in the atmosphere that anything that does make it down isn't going to be worth finding.
Very nice.
I think I've read that if you have aluminum eaves troughs or plastic eaves troughs, you can take a magnet and run them along inside your eaves trough. You can't do it if the eaves troughs are steel, because then the eaves trough is magnetic.
Yeah.
You pick up a lot of dust, and some of that is probably from meteorites.
Yes. To be honest, I have not checked my eaves troughs in the house here I bought in Hamburg. I should do that. You can find micrometeorites that way. Sometimes they're very spherical because that's just the natural shape that they take as they're in free fall. They completely liquefy and they become a little sphere. Sometimes they're a single, if it's a chondrite, it would be a single chondrule that breaks off of, during the airburst. And it just scatters micrometeorites all over the place. Some of those chondrules are very spherical as well because they're a little particle from the early solar system, the solar nebula, as it were, that was out there. And these little spheres of material, of primordial material, were just perfect little spheres floating around in the atmosphere, coalescing into larger and larger bodies, forming asteroids. Then they enter the Earth's atmosphere, explode, and scatter those sphericals all over the place. But they're really amazing little objects if you can find those micrometeorites. I would love to find some. We think we have some small little round things that we picked up on our magnets, but again, we can't without sending it out to a lab for scientific study, which costs money and whatnot, we can't really make that determination. At least I don't have the resources.
We actually have a comment from Joe McBride about magnets in the chat. So he says a good magnet would be the kind that trucks carry around scrap yards and pick up metal in the pathway of tires. They're very powerful. I have one that is 4 feet long and can pick up roofing nails at 6 inches above the ground. Wow. Very cool. Thank you, Joe. Dale, Timmy, do we have any questions coming our way from the YouTube guys?
No, we don't.
Okay, well, fabulous. We have hit the bottom of the hour, so thank you very much, Tony, for an inspiring talk showing all the different
You're welcome.
Yes.
It was my pleasure, Diane.
It looked like Laura had a question. She had her hand up.
Oh, it did not pop up on my screen. Laura, did you have a question for Tony?
Well, it just occurred to me, and maybe he could comment that, you know, when things fall, like let's say a plane crashes and there's a mark on the earth, you know, and then I watched a lot of crime shows, and then they talk about splatter and stuff like that. And you know, let's say you go out and you see one meteor go down, and you go out, and how do you calculate, or do you wait for a calculation from NASA on how it hit, if it bounced, how far it went?
Yeah, good question. So that's based on the mass and velocity of the object that's coming into the atmosphere, and then what it's made of. Sometimes if it's a stony meteorite and it's quite large, it can actually hit the ground before it reaches terminal velocity. Terminal velocity means that it slows down to just basically free fall in the atmosphere. And then it burns out, and then it falls at some, I don't know, 200 miles per hour. Very slow, very slow. They slow to normal free fall about as fast as a skydiver would be falling to Earth, right? Sometimes. And then they hit the ground, and they don't make craters in that case because they've slowed to just free fall terminal velocity. However, some rocks come in massive enough, or they're made of iron or something like that, nickel iron, and they don't break up, and so they don't reach terminal velocity. In fact, nowhere near, and they'll slam in the earth at 20,000 miles per hour.
Whoa.
Create enormous fireballs and craters, and those events do happen, but very rarely on Earth. Very rarely will you find meteorites in a crater, at least fresh ones. You do find meteorites in craters, ancient ones, like the one out in, Meteor Crater in Arizona, for example. They found meteorites there, and other craters. There's craters all over the Earth, and they do find meteorites there. Some are even stony meteorites that were massive enough to hit the Earth at some significant velocity other than free fall. And so, yeah, but recently, no, there's been no reported meteors that have come down and formed a crater, not any time in the past couple hundred years.
Thank you.
Awesome. Okay, any additional questions? Otherwise, we will let y'all go until the next virtual open house. So let's give a hand for Tony for giving one heck of a talk about a uniquely Michigan event.
Thank you, everyone.
Thank you very much for joining us tonight. And everybody, head on out, be safe, have a good weekend. And next weekend is virtual astronomy at the beach.
Thank you, Warren Club. Bye.
Thank you.
See y'all.
Tony.
Thanks, Dale.